Bem-vindos de volta. Agora a gente vai começar as sessões paralelas. Vamos ter agora, iniciando 10h15, depois às 11 horas, também vai ter duas palestras paralelas. Agora a gente vai ter, na sala 2, lá embaixo, Daniel Romero falando de Metasploit, e aqui em cima o Travis Douce falando de aplicações SOA. Depois, então já para vocês, quem não está vendo, a gente tem um panfleto com programação, tem no site, então não deixem de ver. E relembrando que todas vão estar gravadas, então vocês podem escolher qualquer uma, que depois vocês podem ver as gravadas depois. Então, sem mais delongas, deixo com vocês Travis Douce.
Hello, everybody. I'm Travis Douce, and I will be presenting testing Rails service-oriented architecture. One moment. Picking up.
Okay, there you go.
What? I need my notes. Okay, let's start over. My name is Travis Douce, and I will be presenting testing Rails service-oriented architecture. But before we do that, let me tell you a little bit about myself. I work for a company called Big Nerd Ranch, and we are located in the United States, in Georgia, in Atlanta, Georgia, for those of you who are familiar with the geography of the U.S. At Big Nerd Ranch, we write books, we teach classes, and we do consultancy. So we write books about Android development, Rails development, front-end development, iOS development. We teach classes on those things, and we're also consultants. So we build mobile applications, and we do back-end applications. I am on the back-end side of things, and I primarily do Rails development. So now jumping into our talk, what are we going to discuss today? The first thing we're going to look at is monolithic applications. What are they? And then we'll look at service-oriented architecture. And then we'll look at how we test monolithic applications. And then we'll look at testing service-oriented architecture. And then we'll look at the challenges that we face with testing service-oriented architecture. And then we'll look at some strategies that people use for testing service-oriented architecture. And then finally, we'll develop some features for service-oriented architecture and application. So what is a monolithic application, which is represented by this white box here? A monolithic application is typically your standard Rails application. So when you're like Rails new, some project, it's going to be a monolithic application. So that includes the client-side components, which are HTML and JavaScript and CSS. It has a database, which is usually some relational database like Postgres or MySQL. It could be a NoSQL database like Mongo or some other data store. And it has server-side components. So it can handle HTTP requests. It does database queries. It has your domain logic, and ultimately it populates your HTML with the right language. So monolithic applications are deployed as one logical unit. So if you make a change to the system, it requires building and deploying a new version of the entire monolithic application. So let's have an example. Let's say that we have the school management application, and it manages all aspects of managing a school. So a school can have a principal, a school can have teachers can have courses, classes. Students could register and enroll for these courses. Teachers can have tests. Students could take these tests, and ultimately this test could be evaluated by the teacher and say, you got a 100 or 80 on this test. So now that we have this example, that's not right. Let's look at service-oriented architecture. So if we wanted to redesign the school management application to a more service-oriented architecture, it would look something like this. And this is just an example. On the left-hand side, there's an application, and it has a server-side component and a database. And in this database, it has the students table, the teachers table, the courses table, all those type of things. In the middle application, it has a server-side component, and it has a database. And this application deals with grading a student's test. So it has a narrowly focused It's a narrowly focused application. And on the right-hand side, there's another application. It has a server-side component. In this case, it does not have a database, but it certainly could have a database. But in this example, it doesn't. And it has a client-side component. And this application is the user-facing application, the application that serves HTML that users would then interact with. So let's give these names to make it more concrete. We have this, we'll call on the application on the left a school API. And in the middle, we'll call this the grading application. And on the right, we'll call it a web client. So each one of these services, as I mentioned, implements a set of narrowly focused functions. If a user wanted to, or if a teacher wanted to grade a test for a student, they would select, grade test for student in the web client application in the browser. It would then send a HTTP request to the web client application, which would then send a HTTP request with JSON over to the school API, which would then send a HTTP request over to the grading application, where the grading would be done. The grading application will return that HTTP response to the school API, and then back to the web client, and then the web client would ultimately serve up an HTML view that is available in the browser. A trait of service-oriented architecture is that the different applications can be deployed independently of each other. So the school application can be deployed independently of the web client application, and the web client application independent of the school API application. So now that we understand basically what a monolithic application is and what service-oriented architecture is, now we could look at testing monolithic applications and testing service-oriented architecture. And because the architecture is different, they present different challenges in testing. And we'll look at this in more detail. So testing a monolithic application. As I mentioned, this has your JavaScript, your HTML, your domain logic, and your database. So a typical integration test on a monolithic application would look something like this. You have a test, and this test is testing whether or not a student can be unregistered from a school. A test suite may have hundreds or thousands of these individual tests, but this is just one test we're looking at. Typically, before a test is run or the test suite is run, the database is cleaned. So that means any records that were in the database would be removed, and that the database is returned to a pristine state, a known state. And then we have a description of the test. In this case, we should be able to unregister a student. And then we have a portion that deals with creating data. We're using Factory Girl in this example, and we'll discuss this in a little bit. And then there's some state manipulation. We're visiting the pupils path, and we're clicking a button that would be a student's email address, and then there would be an assertion. So we would expect this page to not have the student's email address after it was deleted. And this test passes. My go-to tools in testing monolithic applications are typically RSpec Rails, Factory Girl, and Database Cleaner. And RSpec is a testing framework, and Factory Girl allows us to create data, and we'll discuss that in more detail in a second, and Database Cleaner to clean up data. So I think the best way to understand Factory Girl is to look at an example that doesn't use Factory Girl. So if we wanted to create data, the prerequisite data for this test, we need a student, we need a principal, we need a school, and we have to associate the student with a school and the principal with a school. So if we did this with Factory Girl, it would look like this. There's much less code. It's almost a shorthand for creating this complex data. And in this case, there's a factory that's registered defined called registered student. And we could pass in a custom attribute such as email, which is stewart@school.com. So in short, Factory Girl makes creating data easier. So database cleaner, as the name implies, it has something to do with cleaning the database. And as I mentioned, it cleans all the records that are in the database. So in the on the left-hand side, there's a table that represents the state of the database. And as we walk through this test, the state in the database will change. So we start out with 0 schools in the schools table, 0 principals in the principals table, and 0 students in the students table. And then Factory Girl creates some data, so now we have 1 school, 1 principal, and 1 student. And we clean the database, and now our database has no records. So database cleaner makes destroying test data easier. Let's look back at our service-oriented architecture example using the school management application. Because we want to test the service-oriented architecture, and let's look at testing the web client. So why the web client application is because it presents different challenges than testing the school API application, and that's because we can't use Factory Girl or Database Cleaner in this application. And that's because, as I mentioned earlier, all the data that's needed to drive this application lives in the school API application. So if the web client needed a list of students, it'd have to send an HTTP request over to the school application, where the school application would then return a JSON representation to the web client. So we can't directly interact with the database when we're testing the web client. And this is why writing tests for service-oriented architecture is hard, especially for applications like the web client. So testing Rails service-oriented architecture in the real world. As I mentioned at Big Nerd Ranch, we are consultants. And on the consultancy side, customers would bring us legacy applications that need to be working better, or they might bring us ideas, and we would bring those ideas to reality. Last year, a client came to us with Rails service-oriented architecture, and it had an application like the web client. And so I did a code audit on these applications, and my biggest concern was that the application like the web client lacked robust test. It actually had tests, but the tests were of little value. And the developers on that application knew this. And as all developers, they were under tight time constraints to deliver features. So in the interest of time and the lack of options of how to effectively use the existing tool sets to write great tests for the web client, they moved on. So this is when Big Nerd Ranch came into the picture, and I didn't know how to test the web client either. And the rest of this presentation will deal with strategies that we looked at or tried or I have seen employed in testing other service-oriented architecture. And we'll look at we're going to develop some features, and we'll apply these strategies to developing those features. And in doing that, we'll be able to identify the weaknesses and strengths of each strategy. So what are the other strategies? You can have no test. That's an option, but it was not an option for this client. And I have been part of an application that had no test, and that was not very fun. You could stub HTTP requests from the web client to the school API. And what that means is when the web client's test suite runs, an HTTP request is not sent to the school API. Instead, the response is stubbed to return some known JSON response. We could make HTTP requests from the web client to the school API. And then if we do that, because we're making an HTTP request from the two, if the web client said, I need all your students, then there has to be students in the school API test database to return. So we would see the school API test database. And then lastly, we could create or destroy data in the school API's test database using the school API's RESTful interface. So they give us options to create, read, update, and delete data. So why not just use that? So my experience with testing or developing in service-oriented architecture is that it's filled with bugs. And that's because the strategies that I've used to test have not been very robust. And if you don't use sound testing techniques, there leaves a lot of room for bugs to creep into your code base. So I'm not saying that service-oriented architecture is always filled with bugs. I'm just saying if you don't apply sound testing techniques, it leaves a lot of room for bugs. Now we're going to look at developing some features for the web client in the service-oriented architecture example. And it's also important that we know that there's a developer that's working on the web client application, and there's a developer that's working on the school API application. And we have a customer, and the customer wants these features. So again, this is what the architecture looks like. We're writing tests for the web client, cannot use factory girl, cannot use database cleaner. So here are the features. We need to be able to unregister a student from the school. So that means that there has to be school or students in the school API database so that we can unregister a student. We need to display the number, the count of registered students at the school. So if there's 100 students, we want to see somewhere on the web page 100 students registered at school. And then we want to be able to view the student profile. So the student profile has things or attributes about the student, like the first name, the last name, the email address, identification number, those type of things. And then lastly, we want to be able to edit that student profile. So we want to be able to change a student's email from school or student1@school.com to student2@school.com. So let's build these features. And the first feature is unregistered student from school. So we're going to employ this strategy, stubbing the HTTP request from the web client to the school API. Oftentimes this is done with a gem called VCR. I'm sure you've heard of it. So let's assume that the web client dev has written this feature and the test. And the following is a conversation between the developer on the school API, the web client API, and the customer. And so they're chatting over like Slack or HipChat or something like this. So the web client dev, I finished my feature, my tests are green. The school API dev, great. The web client dev responds, I deployed, and I also told the customer. And the customer replies, the site is down. I'm sure we've never experienced this. And then the web client dev says, what? But my tests were green. And the school API dev responds, I renamed pupils resource to students resource. And I didn't tell you. And then the web client dev says, oh my gosh. The web client dev responds, tell me next time you make a change, please. And the school API dev responds, it won't happen again, I promise. But it does. So in summary, what happened? The web client dev was stubbing HTTP requests from the web client to the school API. And the web client was stubbing the HTTP request to the resource or to pupils when that resource existed. And that's what he bases his stub on. And then minutes or possibly hours later, the school API dev renamed the pupils resource to students and did not tell the web client dev. So he did not update his stubs. And because the web client dev trust his test suite, he deployed. And then he deployed the web client application to production. It was making HTTP requests to pupils rather than students, and then it broke. So this is why you need integration test in service-oriented architecture. And by integration test, I mean when the test suite, the web client's test suite is running, it needs to send HTTP requests to the school API, and the school API needs to respond with real data. So proponents of stubbing might reply, well, if I just updated my stub HTTP request, then when I ran the web client's test suite, a failure would happen, and then I would know that everything would be great. And I would reply that that is a flawed approach because it requires that the school API dev notify the web client dev. Humans are notoriously bad at communication and worse at remembering things. So if you do integration test, you eliminate those human factors from the equation. So reviewing this approach, what are the advantages and disadvantages? If you stub, your tests are going to be fast. You could run 100 or 1,000 tests in the order of seconds rather than minutes for integration testing. The disadvantage is that stubbing, in my opinion, gives you false confidence in the web client's test suite that we just saw. So when to stub and when not to stub these external dependencies. I suggest that if you can control the external dependency, in this case the school API application, if you could pull it down locally and run it on your machine, then you should do integration testing. If you cannot pull down a local copy of the external dependency, for example, maybe you're integrating with a Twitter API, you obviously can't pull that down locally, so you're going to have to stub those requests. So what feature are we on? As a reminder, we're unregistering a student from the school. So the problem with the previous strategy was that the web client dev no longer trusts the web client's test suite. So a solution to that would be, well, let's make HTTP requests to the school API when the web client's test suite is running. So and if we did that, renaming the resource pupils to students would be called. And then, like I said, HTTP requests are sent from the web client to the school API. And then that means we have to seed the school API test database with data. So when an HTTP request is made, there's data to be returned. And then we have to start the school API server in the test environment. And why the test environment? And that's because when an HTTP request is received by the school API, we need to create data or destroy data in the test database and not the development database. And then finally, web client needs to be issuing HTTP requests to the school API, so there has to be some sort of coordination between the two applications. So an overview of the state of the school API database and the web client test suite before running our test suite. So we seeded the school API test database with one school, one principal, one student, and we have one test. And this is what the test looks like. Again, we have this table on the left, and it describes the state of the school API test database. So we have one school, one principal, one student. We have this function here that fetches all the students and grabs the first student because we don't know the student's email address to delete in this step. So then we click the delete student email button. There's a student that's deleted, and this test passes. That's great. We have a passing test. But we still have state that's persisting that is still exists in the school API test database. One school, one principal, 0 students. But we have a passing test. Let's not worry about it now. Let's move on to the next feature. So this feature is that we need to display the count of registered students. So if there's 100 students, we need to display there are 100 students registered. So we have to reset the school API test database because there's state that's persisted from the previous test suite run. And we reseed it with one school, one principal, and one student. And now the web client has 2 tests. So let's run the test suite. The first test passes. The second test, where you're running, we fetch the students. And we have a failure. So why do we have a failure? And that's because the previous test deleted the student that this test needs. So the student at this point is nil, and we send email to nil, which results in the failure. So there has to be a better way to do this. But before we investigate that, let's review the advantages and disadvantages of this approach. This approach gives us more confidence in the web client's test suite because we're integrating with a school API application. The disadvantage is that now we have to manage the school API test server. We have to have it running locally on our machine. If we're using some version control, which hopefully we are, we have to make sure we're running it against the most recent code. We have to make sure we're on the correct branch, perhaps. And then it bleeds state between tests. By bleeding state, that means there are records that are existing between tests. So the problem with this strategy is that we have to frequently update the seed data for the school API test database. So the solution is, well, let's just create the data that we need right when the test is run, kind of like Factory Girl does. And in doing that, we could use the school API's RESTful interface to do that. So let's just create the test data doing that. So now we no longer have to seed the test database. So we start the school API server in the test environment, and the web client issues HTTP requests to the school API. And as a reminder of what feature we're on, we're displaying count of registered students. So the customer chimes in. You there? Web client dev. Yep, need something? Customer. I forgot to mention, you cannot create a school through the school public API, through the RESTful interface. So this happened to us. in a real application. So what do? You certainly can't use strategy 3 because we can't create a school through the school API's public RESTful interface. But before moving on to the next strategy, the advantages and disadvantages of this approach. So it would give us confidence in the web client's test suite because we're integrating with the school API application. The disadvantage is we have to still manage the school API application and its server. This approach is not possible in this example because of the constraint the customer just gave to us. It would be difficult to create complex data. So imagine if we were testing that when a test is graded for a student, that it results in the right test score. That would require that we have to create a student, a principal, a school, a teacher, a course, a test questions. And that's a lot of data to create through the RESTful interface. And to delete all that data, if we wanted to do that through the RESTful interface, we have to keep up with all the IDs then to delete it. So it just becomes complex. And then this bleeds state between tests. So the problem is with our last failing test was that we cannot create the school that we need through the school API. And the solution is create a school, but this should read, but not with the school API. So that means we need a strategy 4. So this is what I want to do. I want to be able to create test data in the school API test database with something like Factory Girl. So it would look something like this. This is the test that we have previously seen. It would look like Factory Girl, but it would have the word remote in front of it. And it has the same interface that Factory Girl gave us, so we could invoke create on it, and we would say, hey, I want to create this registered student. And then that would then create all these records in the school API test database. So let's look at that approach. And we'll call this strategy Remote Factory Girl. So this approach requires 2 gems. It requires Remote Factory Girl and Remote Factory Girl Home Rails. And Remote Factory Girl lives in the web client application. Remote Factory Girl Home Rails lives in the school API application. The Remote Factory Girl sends HTTP requests to the school API application, and it sends over the parameters, the name of a factory, and any custom attributes that you want associated with that factory. And it sends it to a route that's enabled by Remote Factory Girl Home Rails. So Remote Factory Girl Home Rails lives in the school API application, and it makes a controller and a route available only in the test environment. And it has a create action, which takes a parameter, the name of the factory, and some attributes, and use those attributes to invoke a factory that is defined to create the test database. So now we could create all this complex data. So how do we do that? We install Remote Factory Girl Home Rails in the school API. So you put it in the gem file. Factory Girl has to be also installed. This is a school API application. You have to explicitly enable it in the environment in which you want it to run. And this is probably the same group that you included in the gem file. And then you have to add a route. So the Remote Factory Girl could communicate with us, and we're adding an endpoint called Remote Factory Girl. So then we have to install Remote Factory Girl in the web client. And this is what it looks like. You include it in the group test, in the gem file, and you configure it. We want to send HTTP requests with Remote Factory Girl with localhost on port 4000 to this endpoint. And this is the endpoint that we just created with Remote Factory Girl Home Rails. So then we start the school API server in the test environment, and we issue HTTP requests between the web client and the school API. So now, where are we at with our features? We want to display the count of registered students. So if there's 100 students, we want to say we need to see 100 students on the web page. Now, the state of the school API test database and the web client, we no longer need to see the school API test database any longer, and the web client has 2 tests. So let's run them. Remote Factory Girl is invoked. We send over integrated in the school API test database. We delete that student. We remove the student from the school API test database. We go on to our next test because that one is passing. And this one is also passing. That's great. So now the state of the school API test database is that we have 2 schools, 2 principals, and 0 students, but we have 2 passing tests. This means we're making progress, and the customer has to be happy. So the next feature, we want to be able to view the student profile. Again, we want to see the student's first name, last name, email address, identification number, these type of things. So we have to reset the school API test database because there was state that existed from the previous test suite, but we don't have to seed it, and now the web client has 3 tests. The first test we run, and it's passing. The second test we run, and it's passing. The third test we run, and it's passing. That's great. We have 3 passing tests. But we're accumulating the state in the school API test database, and that's probably going to haunt us later on. But we have 3 passing tests. And then the customer chimes in again. They always are chiming in. And the customer says, "You there? School API dev. Yep, what's up? You need something?" The customer, "I forgot to tell you, the student emails have to be unique." We'll say, "Not a problem. We could do that." So then the developer on the school API application implements the constraint on the student's email address. And we move forward with the next feature, which is to be able to edit the student profile. So we want to change the email address of the student. So the state of the database is, in the school API database, we had to reset it because there was state that existed previously. And now there are 0 schools, principals, and students, and we don't have to seed it. And the web client has 4 tests. So the first test is passing. Second test is passing. Third test is passing. And now the 4th test fails. So why does this test fail? And that's because the previous test created a student with Remote Factory Girl with the same email address as we're trying to create here, which is stewart@school.com. So there has to be a better way to manage this. But before we investigate, let's look at the advantages and disadvantages of Remote Factory Girl. We have more confidence in our test suite. That's because we're integrating with a school API application. We could create all this test data that's not available through the school API's API. The disadvantage is we still have to manage a school API server. There's still state that bleeds between tests. So that's our problem. The state in the school API test is persisting between test and test suite in the web client. So the solution is that we want to destroy the test data after each test and after the test suite with something called Remote Database Cleaner. So this works very similar to Remote Factory Girl. It requires 2 gems, Remote Database Cleaner, which lives in the web client, and Remote Database Cleaner Home Rails, which lives in the school API application. Remote Database Cleaner sends an HTTP request over to the school API application, and it hits an endpoint and a controller that's enabled by Remote Database Cleaner Home Rails, and when invoked, it cleans the school API test database. So we have to install Remote Database Cleaner Home Rails in the school API application. We add it to the gem file. Database Cleaner has to be included. We enable it in the environment in which we want it to work. In this case, it's in the config environment's test. And then we give it a route, and it's Remote Database Cleaner. And then we install Remote Database Cleaner in the web client. So we add it to the test group. We configure it in spec helper. So we say send HTTP request with localhost on port 4000 and send them to this endpoint, which is enabled in Remote Database Cleaner Home Rails in the school API application. And then we configure it with RSpec. We say clean the database before the test suite runs and after each test. And then we have to start the school API server in the test environment. And then the web client and the school API have to coordinate between each other. So the last feature, again, we're editing the student profile. And now the state of the school API test database, after we reset it, because it was state from the previous test suite run, is there 0 schools, principals, and students. And the web client has 4 tests. So the first test is passing. It starts out with no data in the school API test database. Second test is passing, and it starts out with 0 state in the school API test database. The third test, again, starts with 0 state in the school API test database. And the fourth test starts with 0 schools, or it ends with 0 schools, principals, and students in the school API test database. And then this is the state after the test suite runs. And this, we don't want any state left in the school API test database. And we have 4 passing tests. And this is what we want, and our customer is really happy. So the advantages and disadvantages. We're not bleeding state between tests with Remote Database Cleaner, but we still have to manage the school API server. So now we're done with our features and our test suite. And almost a side effect of using Remote Factory Girl and the other gem, and Remote Database Cleaner and the other gem, is that your applications are now set up for continuous integration. So now your applications that make up the service-oriented architecture, you could run with a service like Jenkins. And that's awesome, because my suggestion is that you need to be running continuous integration with service-oriented architecture. So the takeaway from this presentation is that integration tests gives us a lot more confidence in service-oriented architecture. It requires more setup initially, but in the long run, it pays dividends. You will experience much fewer bugs. If you are interested in this approach, I have a blog that's written on the Big Nerd Ranch website. And there's also an example that I put up on GitHub. And I'm sure these slides will be made available somewhere. And so this application or this repository on GitHub, it has the school API application, it has the web client application, and they're configured with Remote Factory Girl and Remote Database Cleaner. So what did we learn about in this presentation? What did we look at? We looked at what are monolithic applications, what is service-oriented architecture. We looked at testing monolithic applications. We looked at testing service-oriented architecture and the challenges that it faces, and then strategies for testing service-oriented architecture. And then ultimately, we developed some features for service-oriented architecture. And that's it. Does anybody have any questions? Yep. So let me repeat the question.
Oh, sorry.
So everybody else could hear. Or do you want to repeat it?
You can hear me?
Mm-hmm.
Okay. In a configuration level, the one application needs to know specifics about the other application. Or what controller, what specific URL they need to call. And there's a way to make it more transparent to the other application. Or maybe we can do something to separate the configuration from the test, maybe?
I don't know if I fully understand your example, but the way that I understand it is you're saying that the two applications are coupled to each other by the structure and the URLs that require...
Because the SOA tells us to not couple our applications, maybe. You could change your application for other that complains with the same API, and everything needs to work fine. It's like a contract between the applications, but not configuration about the two applications. I don't know if I can pass to you my doubt, but...
Yeah, maybe we could talk after.
Okay.
And I could more fully understand your question.
Okay.
Hi. I was wondering if you have an opinion about using metrics as as sort of a measure in production, are things working when you have a SOA architecture? So I'm kind of referring to anarchy kind of style of development that people like Fred George are talking about, where, I mean, he goes to extreme. He says, like, we don't even write any tests, but we have a lot of metrics that we use as to alert us if something goes down or something. So maybe there's also some middle ground. So maybe you can use, like, for everything you do, you have a lot of metrics to alert you if something goes down.
So the way I understand your question is that why not use metrics as a measure to see if your applications are working collectively?
Some sort of a complementary measure.
Yeah, I don't see why not. I think you certainly do need test. And probably something I should have said in the presentation is that I think the biggest benefit of this approach is during the development of the applications, because that's when the RESTful interfaces aren't well defined, especially when you have multiple developers working on different applications. Things are constantly changing out from under you. So I think certainly that it benefits in the development. To answer your question about metrics, I've not used it or have seen that approach, but I certainly don't think it could hurt. I would be interested in learning more about it. And like I said, this is just something that we came up with that happened to work. So I'm sure that there's some weaknesses to it, and I would love to know your perspectives to help make it better.
Hi, how are you? You talk about when you use Twitter API or some credit card stuff that you can't manage the other service. You talked about this approach, but you didn't talk about how do you manage this. You would still Stub?
So the way I understand your question is when you have a third-party service, let's say like it's a credit card transaction service, how do you manage that interaction for the tests? Yeah, I think your only option is to Stub. Like, I would probably use VCR to do that, if possible. But then ultimately, if the third-party service's API changes, then you'd have to update your cassette or Stub. But hopefully that external service is versioned. So then when they release a change, it's a new complete version where you would then re-record all your cassettes.
Thank you, Travis. This strategy can be used with Ember.js, for example, and JavaScript frameworks.
Sure, and that's a really great point. Not only can it be used with Ember.js and other frameworks, it could also be used to integrate mobile applications, iOS applications, a lot of different applications, because really if your backend is in Rails and you have Factory Girl and Remote Factory Girl home Rails installed and Remote Database Cleaner, you could do full integration testing with these other applications that you just mentioned. Because creating the client is really easy. I don't have the slides with me right now, but I wrote a JavaScript client for this in, like 15 minutes. It's really, really easy. So you could create clients for all these other applications. If your backend is not in Rails, perhaps, then you have to create that functionality. And that's okay, because I think it's more the concept that's important rather than the specific technology that we're using.
Alô?
Oi.
Infelizmente, alô? Vou dar a última pergunta.
Hello. I've got a question here. Using the last approach, how do you deal with the test job isolation in Jenkins? For example, you have only one server instance for the school API, and a lot of jobs are sending requests using these remote factory gears. How do you do it? If you are using database cleaner, you have transactions, you can create different databases for the test using build ID from Jenkins, but I don't know how to solve this using your approach.
Can you repeat your question? I'm sorry.
The question is, how do you deal with test job isolation in Jenkins?
how would you use this within Jenkins?
How do you deal with
How do you deal with job isolation?
How do you deal with job isolation in Jenkins?
I'm not sure. I would probably need your help.
Let me. You don't know how to do this?
No.
I would use different school API instance. I open maybe one for each job.
Well, then
Use
we should
different
talk.
ports. One
Yeah.
solution. Or serialize all jobs.
Okay.
Bad solution.
Yeah, that's great advice. We should talk after this presentation.
Okay, would be nice.
Okay, thank you. Thank you so much. I think people have a lot of questions. Hope you're available. Ok, 1 minuto. A gente vai fazer a troca só agora. Vamos ter o Marco da Semaphore, que é uma empresa de Continuous Integration. E na sala 2 a gente vai ter o Thiago Scaloni falando de mRuby. Então, 2 minutos só para fazer a troca aqui.